Okay, so we are asked to check for the number 10, we are asked the orthogonal trajectory of a function. Okay, so let's see how we are going to do that. That's the question 10. Okay, so this one's so the orthogonal trajectory of a family of curves of this. So the thing is y equals to e power x plus c. We are asked to find the orthogonal trajectory. Okay, of course we all know what the orthogonal trajectory will be. First you have to differentiate, so the y, the x will be equals to e power x like this. Okay, and so we then find the negative 1 over dy dx. Okay, so and then integrate it like this. So that will simply mean that this will become negative 1 over e power x like this. Okay, so here we then integrate. So let me just write dy dx is equals to negative 1 over e power x. So we integrate to get our y, and so let me do this, erase this ones here. Yeah, okay, so this will imply that we have y to be equals to integral of e power negative e power negative x. Integrating this one, y will be equals to negative e power negative x all over negative 1 plus c. And so let me clean this. Okay, so we will now have y to be equals to e power negative x plus c. Okay, and then the answer will just be A. So number 10, the answer is A. Good. That's all you have to do. You don't need to do any big job. Okay, so we are going to number 11. So let's look at number 11. It is saying that what is it saying that we should do? Sorry. Okay, so number 11, so the following differential equations is homogeneous. Okay, so if a differential equation is homogeneous, then what we have to know is if we have an equation f of xy like this. So if we have an equation like this, and then if we are talking about homogeneous equation, when we introduce lambda x, lambda y, and then this one we can write lambda of 0 f of x y like this. Okay, when the degree of homogeneity is 0, then we say that it's a differential equation. Okay, and so with these ones we have y prime to be equals to x cubed minus y cubed all over xy. Obviously this one, when we introduce lambda, we are not going to get anything, because even here that will be lambda cube, here will be lambda squared, and so in all we get lambda, still lambda inside if we factorize lambda out. So this is not even a homogeneous differential, homogeneous function. Now let's look at y squared minus 4ty plus 6t squared. So we have y prime equals to y squared minus 4ty plus 6t squared all over t squared, like this. And so if we introducing lambda, we'll have y lambda squared plus minus 4t lambda y lambda plus 6 t lambda lambda 60 lambda squared all over t lambda squared. So here we get y squared lambda squared minus 4ty lambda squared plus 6t lambda squared all over t squared lambda squared. And so for the top, I can factorize lambda square out all over the y squared minus 4ty plus 6t, like this, all over lambda squared t squared, like this. So here obviously you realize that I have lambda power t minus 2 into brackets the function f of x y, like this. So this becomes lambda power 0, and so I'll have y prime to be equals to this. So once I get this, then obviously it is very clear that this is a homogeneous differential equation. Okay, and so that is all. We don't even need to go further. So the answer there is B. So number 11, the answer is B. Number 12, it says solve the IVP. This we are required to solve this particular IVP, number 12 error today. So let's look at question 12 and see. It goes like y prime equals to x plus 1, y plus 1, y of 0 equals to 1. So here we can write it as dy dx equals to x plus 1, y plus 1, which is separable. We can separate. We have dy over y plus 1 equals to x plus 1 dx. And solving this, we have ln y plus 1 equals to x squared over 2 plus x is x squared plus, let me say, ln c, based on the answers to the question. And so from this we can have ln y plus 1 all over c equals to x squared over 2 plus x, like this. And take e of both sides. We have y plus 1 over c equals to e power x squared over 2 plus x. So this will imply that we have y plus 1 equals to c e power x squared over 2 plus x. And so our y will be equals to c e power x squared over 2 plus x minus 1. Now we apply the condition, which is y of 0 equals to 1. So this will imply that y of 0 equals to c e power, this will be 0 plus 0 minus 1 equals to 1. So we have c e power 0 minus 1 equals to 1. C minus 1 equals to 1. Sorry, this is 1. And so this will imply that we have C to be equals to 2. So therefore we have our y of x goes to 2e power half x squared plus 2x minus 1 as our solution. By factorizing half out, we multiply the x that was there in the solution by this place, so we multiply here by 2. So when we factorize this half out, so that when we multiply it back, we get back our x here. So that is the solution for the question 12. Thank you for watching. So the following equations is exact. It's exact. Exactness means that you have to test. Okay, m of x, m of this, you have to test both sides. Okay, so if we do that test, exactness. So I think this is very long, but let me try and see which one is actually exact. So I'll just show you how to go about it, then we'll show which one is the answer. So if you look at the A, we have the y, the x being attached to one term. So here you can multiply each term by the x. So in that case, we have our y cos xy plus e power xy dx, like this, then plus x cos xy plus x e power xy, like this, sorry, plus 2y, all this dy, all this equals to 0, this is equals to 0. So here you take this one, you take this one, and you test whether this one is actually your m of x or del m del x, and then this one here is your n of y, and that is equals to del n del y, like this. Okay, so you check whether you now check for m of y and check for n of x. If this is equal to this, then we say that it is what? Exact. Okay, it is exact. If they are not the same, then it is not exact. Okay. So that is how it is going to be. I'm not going to do that one here because it's just about differentiating partial differentials. So you just have to try and do them. And but if you do them, I think, or let me just try one for you. So I have y cos xy plus y e power xy. So let's assume this is my m. Now m y will be equals to, so remember that I'm doing everything with respect to y. So here I'll use product rule. I'll keep y and differentiate this. So that will be negative xy sine xy plus cos xy plus here to the same thing. I'm keeping the x here is a constant. So if I do that, that will be xy e power xy plus then I keep this and differentiate this, that's just e power xy. So that's the differential for this part. And if I take the n of x, so n of x, I'll just get the n is let me write it down first. X cos xy plus x e power xy plus 2y, like this. So differentiating this with respect to x, then I will just be having negative xy sine xy plus cos xy. Then doing this one, I have plus x, keeping this one, doing with respect to x, xy e power xy, then plus e power xy, then the other part will just be 0. Okay, will just be 0. So looking at these two things, looking at this one here, looking at this, and this thing here, they are the same. Okay, so we can see that the answer is just A. Okay, the answer there is A. So coming back here, question 13, number 13, the answer is A. Okay, so for now, we will pause the video here because it's becoming very long. Then we proceed to look at the rest of the questions. Okay, so let's look at question 14 of our solution set to the ordinary differential equations. Question 14 says, find the integrating factor of the equation y plus xy squared, all that dx minus x dy equals to 0. And so we have y plus xy squared dx minus x dy all equals to 0. So here right now our m is equals to y plus x y squared, and now n is equals to negative x. Okay, so in order to check whether this is exact, we have to find m of y and n of x. Okay, and m of y means by differentiating this thing partially with respect to y. Okay, so it means if we differentiate this one, we get 1 plus this one. This x here is a constant, so that will just be 2xy. Now n of x is negative 1. Okay, and now these are not exact because this one is not the same as this, so it's not exact. But we can try to see if we subtract the two, m of y minus n of x, this becomes 1 plus 2xy minus 1, and this gives me 2 plus 2xy, like this. You know where that 2 is come from, this become positive, so 1 plus 1, that's 2. Now, and of course, if you look at this one, it's like we can divide it by something, so we have m of y minus n of x all over this one was supposed to be over n, and now if we take over negative m over negative m, in other words n of x minus m of y over m. Okay, the one that appears here, this one too is just the same as n of x minus m of y all over m, like this. Okay, so now this one will become, already we found this one, which is this, and that's 2 plus 2xy all over negative m. Our m is y plus xy squared, like this. But here we can factorize 2 out here, so we have 2 into brackets 1 plus xy all over. Can factorize y out here, so we get negative y brackets 1 plus xy, like this. And so this and this will go, so we have negative 2 over y. And so to find the integrating factor, that will just be, so this one will depend on ODE, so e power this, so we integrate this. Okay, so integrating this one, just get e power negative 2 out, integral of 1 over y dy, and so we get e power negative 2 ln y. Now okay, so that will be e power ln y power negative 2, this and this goes, we get y power negative 2, which is the same as 1 over y squared. So this is the integrating factor, and the answer there is D. Okay, so for 14 we have D as our answer. Now let's go to 15. Okay, let's go to 15. 15. So we have 2x plus 2 dx plus 2y plus 3 dy equals to 0. I have to find the solution at 1. Of course, let's check and see. M is equals to 2x plus 2. M of y is equals to 0, because this x is a constant, this is a constant, so everything there, if we differentiate with respect to y, we get 0. Now n is equals to 2y plus 3. Now n of x is equals to 0. So since these two are the same, conclude that it is exact. Once it's exact, then we can proceed to find the solution. Okay, and the solution can be written as u of x y equals to the integral of maybe m dx, because the m was differentiated with respect to this one is respect to x, so we just integrate it by respect to x to get the original thing from which it was differentiated, plus f of the other variable, which is f of y, because so right now our m is 2x plus 2 plus f of y. So here we get x squared plus 2x plus f of y as our u of xy, like this. But we know that when we differentiated u with respect to y, that is the same as n. Here, when we differentiate with respect to y, same as n. So we can do that. So u of y equals to, we differentiate this with respect to y, this goes to 0, this goes to 0, so we have f prime of y. Okay, and that will equals to n. F prime of y equals to n. Now what is n? N is 2y plus 3. 2y plus 3. So to get f of y, we integrate both sides. We get f of y equals to y squared plus 3y, like this. Okay, so right now, but we know that our u of xy equals to, is up here, s squared plus 2x plus f of y, s squared plus 2x plus f of y, which is now this, y squared plus 3y plus c equals to 0. Okay, so this is our solution, but it is an IDP. We have this condition here, y of 1 equals to 0, so s is equals to 1, y is equals to 0. So this will imply that we have 1 squared plus 2 into brackets 1 plus 0 squared plus 3 times 0 plus c equals to 0. So this I'll get 3 plus c equals to 0. So c equals to negative 3. Now rewriting this, we have this will imply that we have x squared plus y squared plus 2x plus 3y. Now c, we replace it here, minus 3 is equals to 0, and this is the solution. Okay, and so if we look at them, the answer there is B. So 15, the answer there is B. Now 16, we have y prime prime minus 3y prime plus 2y goes to x. We are asked to find a particular solution. So here we are going to use the method of undetermined coefficients. So this is x, it's a linear function, and so we can write y of p to be ax plus b, because all linear functions are of this form. Okay, now we differentiate it once. Y of y prime is equals to a, y prime prime is equals to 0. So we substitute back. So let's substitute back. Have 0 minus 3 a plus 2, the y is ax plus b, all is equals to x. We are just substituting these values here into the differential equation, and so get negative 3a plus 2ax plus 2b, all equals to x. So get negative 3a plus 2b plus 2ax equals to x. We do comparisons. So comparing the x coefficients, so this 2a will be equals to 1 here. So 2a equals to 1, this implies a is equals to 1 over 2. Now negative 3a plus 2b is equals to 0. 2b is equals to 3a. b is equals to 3 over 2a. But a is half. So this implies that we get 3 over 2 into brackets 1 over 2 equals 3 over 4. So therefore our y of p equals to ax plus b, but our a is half, our b is this. So this implies that y of p is equals to half x plus 3 over 4, like this, and this is the answer. And when you go, the answer there is D. So 16, question 16, the answer is D. Okay, so we have question 17, which says that find the solution to the first order differential equation. So that will be the last one on this particular series. So question 17, so this was 16, now we are looking at question 17. So we have y prime plus 3y goes to e power t at y of 0 equals to negative 2. This is a first order differential equation which you can solve using integrating factor approach. So my integrating factor will depend on the t. So mu of t equals to e power the integral of my p of t, which is 3 dt, and this is just e power 3t. So my integration factor is e power 3t. So my y of t will be equals to integrating, this is my q of t, so e power t times e power 3t plus c, all this over e power 3t. So doing this, get integral of e power 4t plus c all over e power 3t. And now we do this, get 1 over 4 e power t plus c e power 3t, but this is negative because it's coming down, it's coming here. When we integrate this, we get 1 over 4, then the whole function. Okay, it's just like you write the function or divided by the differential of the power here. Okay, so if we differentiate this, we get 4 and e power 4t all over 4. That's just 1/4 e power t. And when we divide by the integrating factor here, because it was 4, we will now have this. And so that's just the final answer. This one, you should be able to integrate that one. So e power t plus c e power -3t, like this. That is our y of t. But we have an IVP, initial condition, which is this: y of 0 equals -2. So y of 0 equals to 1 over 4 e power 0 plus c e power 0 equals to -2. So you get 1 over 4 plus c equals to -2. C equals to -2 minus 1 over 4 equals -9 over 4. So therefore, our y of t is equals to 1/4 e power t minus 9 over 4 e power -3t. That's our final answer. And so the answer there is D. So that's 17. The answer is D. So 17, the answer is D. Okay, so I'll stop here, then we'll continue from the next episode. Thank you for watching. I will continue with the next set of questions. That's 18 going.